Welcome to section 3.1, part 2. This is where we're going to go through some of the harder equations and even some of the story problems. So I've already formatted a couple of things if you watched the part 1. And the first thing I want to do is start with solving for a variable with just a bunch of variables. And it looks a little daunting at first. Don't let it scare you. Just work through it just like we did on the other ones. The order of operations backwards, and to get rid of them you do the opposite. So here I have kind of the formula for interest, but it's not quite because I don't have the y. But that's okay, it's just some formula I gave you, and I want to solve this for r. Okay, so the first thing I want to do is to see, oh, the r is stuck inside the parentheses. So I could go ahead and do the distributive property, but I don't want to do that. I want r to be alone, and if I distribute this p, it's going to be stuck with this p, and I don't want to worry about that. I could if I wanted to, and if you choose to do that way, that's totally fine. But what I'm going to do is, since I have these parentheses, I'm just going to get rid of this p first. How do I do that? By dividing both sides by p. So if I have p divided by p on the right side, I have to do it to the left to keep things balanced. And p divided by p ends up canceling out. So I'm going to highlight this now. Now that I have everything gone except 1 plus r, I can get rid of these parentheses. They can drop off. And to continue solving for r, I need to isolate the r. Since I have this 1 being added, I'm going to get rid of it by subtracting it from both sides. If I subtract it from the right side, it cancels, and then I have to subtract it from the left to keep things balanced. And there we go. R is isolated, and there's my answer. And if I wanted to reverse that so that the r was on the left, since traditionally the r or the variable that you're solving for is usually on the left, you could go ahead and do that, but this is fine. Okay, our next one. V equals 4/3 pi r squared HL. And we want to solve this for L. So the first thing I want to do is kind of evaluate what's going on here. I have a multiplication, another multiplication, another multiplication, and another multiplication. So since these are all being multiplied, I really don't have a whole lot to do except divide. But I would like to work with this fraction on the front first, and then I'll go through the rest. Since I have 4/3, I'm just going to copy and paste this down for my next step. Since I have 4/3 and I want to divide by a fraction, you're really multiplying by the reciprocal. So I need to multiply both sides by 3/4. The reciprocal. There we go. And there we go on this side. So if I have 3/4 times 4/3, those will cancel out because it ends up being 12 divided by 12, which is 1. And 1 times whatever is on that side is left with whatever it's on that side. Now over here, oops, I didn't change this to the reciprocal. 3/4. There we go. Now I have 3/4 times v. I'm going to go ahead and put the v up on the top just to keep it nice and pretty. So I'm going to put 3v. Okay, so now I have 3v equals pi r squared HL, and I'm solving for L. So I want this L to be all by itself. Since everything over here is being multiplied, I can just divide everything. So I'm going to divide by pi, which we will find in here, pi, and then r squared, and I'm just using my arrow buttons to go in and out of those different formats that I've put in, and H. Okay, so now you'll notice I did these all at once. Some of you may be thinking, why didn't I just do it one at a time? And I could have. This is just really fast, and because they're all being multiplied, and that's in the same step as dividing, I can go ahead and get rid of all of those all at once. Instead of deleting these, though, I'm going to show that they're canceling out. There we go. But if I did it on the right-hand side, I must do it on the left-hand side. So over here, I need to divide this by pi r squared h. But again, it's working with a fraction, so I need to multiply by the reciprocal. So I'm going to multiply this by 1 over pi r squared h. There we go, and I'm going to unstrike that through because that one hasn't canceled out with anything. So on the right hand side, I am left with just L. So I'm just going to delete all that and put L. And on the left hand side, multiplying fractions, those become one large fraction. I know there's a small space there, but you can just draw that all the way through. And 1 times 3v is still 3v. So I can delete that as well. And if you don't like how that's formatted, we can cut that out and put it over here and just get rid of this one altogether. There we go. There's our answer. 3v over 4 pi r squared h. And I'm going to highlight that as the answer. All right, the next one. P equals B plus capital B plus small a plus small d. And we'd like to solve this for lowercase a. So now I have everything on this side. It's all being added to a. And to move it to the other side, to isolate the a, I need to subtract. So I'm going to subtract a smaller case b, an uppercase b, and a lowercase d. But if I do it on the left side, I must also do it on the right side, or the right side I need to do it on the left side. So I'm going to minus a smaller case b, an uppercase b, and a lowercase d. B minus b cancels, capital B minus capital B cancels, lowercase d minus lowercase d cancels, and I am left with, only on that side, a. There we go. A equals P minus lowercase b minus capital B minus lowercase d. Now if you would like to reverse that, since most things are formatted as A equals, so the answer or the variable you're looking for comes first, you could go ahead and reformat that. That's okay. But either way, it's the same answer. There we go. All right, let's move to our next example. S equals U plus 1/2 AT squared, and we want to solve for U. It looks a little daunting at first until you look at it just a little closely and nothing is attached to the U. It's just being added to something, so we just need to subtract that from both sides. So I'm going to subtract this part. Subtracting it on the right hand side cancels it. And then I have to subtract it from the left hand side to keep it balanced. And we're done. Deceptively easy. Okay, let's move to the next one. This one's a little harder. This is the reverse of the distributive. Notice how I have 4y plus py. That y has been distributed in to the 4 and the p. So what I want to do is undistribute it. This is a little bit like factoring. Some of you may have heard that a long time ago. Don't worry about it, we're not going into it. I'm just going to do the reverse of the distributive here. Now double check. Let's see if I have y on the outside. So I pulled it out of the 4 and I've pulled it out of the p and I've put it out in front with a set of parentheses. Let's double check it. If I were to times the y into the 4, I'd get 4y. Check. Y times p would give me py. Check. So I've pulled it out of the distributive correctly. Now I only have one y, which is perfect. That's what I need. It's being multiplied by this 4 plus p, so I need to do the opposite, which is divide by this. So I'm going to cut it out of there. Dividing it cancels it out. And on the right hand side, we'll divide by it there. And there we go. There's our answer, is y equals 6 divided by 4 plus b. And I'm going to highlight that as the answer and move on to the next one. Number 6. All right. This is reading out some questions and trying to figure out how to set it up. 10 less than. This is really translating from English into math symbols. So those of you who have learned another language kind of understand this, that I'm taking it from one thing and I'm moving it to the next. And that's really what all math is that we're translating. So if I see 10 less than, that means that I need to subtract 10. And you'll think, wait a minute, it says 10 less than. Shouldn't it be 10 minus? Well, let's think about it. If I have 5 things less than somebody next to me, I would take the number that they have and subtract 5. So this one is kind of backwards of what you would think. Minus 10. So I have 10 less than. So I'm going to put minus 10. And I need to subtract that 10 from something. So I come up here, and what's the next part? 6 times a number. Well, that tells me exactly what I need to do. 6 and times. So I need to do 6 times a number. Well, it didn't tell me what the number was, so I'm just going to put some random variable down. I'll pick n to stand for number just because. Okay, so I have, let's read that again, 10 less than, subtract 10. 6 times, so I need 6 multiplied, and I know that this 10 less than comes second. A number, since I don't know the number, I pick something, is 74. Is means equals in math, and we have now translated from English to a math sentence, and we just need to work it out. Solving for this number, I need to add 10 to both sides, so I get 6n equals 74 plus 10, which I'm going to go ahead and replace with 84. All right, now my next step, I would go down further, but it kind of messes up my formatting, so I'm going to come over here a little bit. Now I have 6n equals 84. I want to isolate the n, so I need to divide by 6 to get rid of the multiplying by 6, and do that on both sides. If I do it on the left side, I'm left with n. If I do it on the right side, 84 divided by 6 gives me n equals 14. And that answers our question. What is the number? The number is 14. Let's go ahead and try and translate this next one. 61 is. So I'm going to stop right there. I am going to write 61. Translating from English to a math symbol, is means equals. 5 more than. Just like in problem 6, when we see less than, more than also reverses. So, more than. So I add the 5 to something. Now I don't know what that is yet. I'm just going to write add 5 and then move on. More than 7 times a number. 7 and times, well that tells me I need to do 7 times a number. I don't know what it is, so I'm just going to pick a random variable. In this case, just to mix things up, I'm going to pick m. There we go. So let's reread this and make sure that I've translated correctly from my English sentence to my math symbol sentence. 61 equals 5 more than, that's the reverse one, so I add 5, 7 times a number, 7 times some number, and that goes before the 5 plus. There we go. So now it's just a matter of solving it. So I have 7m plus 5 and I want to isolate the m. So I'm going to subtract 5 from both sides. 61 minus 5 equals 7m. And subtracting 5 from the right side cancels it out. There we go. So 61 minus 5 gives me 56 equals 7m. Then to get rid of the 7 connected to the m, I do the opposite, which is divide by 7. And I have to do that on both sides. On the right side, 7 divided by 7 is just 1, so 1 times m is m. So I'm only left with the m over here. 56 divided by 7 is 8. And there's my answer. Let's move to the next kind. Two numbers add to 110. So I'm going to say two numbers. Let's do f for first, add s for second. Adding those together will equal 110. The second is 56 larger than the first. So I'm going to write the second part right here. It sounds just like our translation part from 6 and 7. The second, since I picked s for second, I'm going to put s. The second is, translating from English to math, is an equal sign. The second is 56 larger than, just like more than, that's the reverse kind, which means I need to add 56 to something, but I haven't read that something yet. Is 56 larger than the first? And I put f for first. There we go. Now it's just a matter of substituting. And so I'm going to come up here a little bit to move to my next step since I don't want to unformat everything underneath of it. So here I have first plus 56 is the second number. So I'm going to substitute that into my first equation. First plus, instead of putting second, second is first plus 56. So I'm going to put in first plus 56. So I've substituted, see where this s is. If this is also s, I can take this and move it in there, insert it. So that's going to equal 110. So my next step will be combining my variables and solving for f. So I have 2f here, adding those together, plus 56 equals 110. So if I want to continue solving for that f, I'm going to move to the next step, which gives me 2f. I need to subtract 56 from both sides. Subtracting it from the left side cancels it out, which gives me 110 minus 56, which gives me 54, and I didn't write that down over here, minus 56. And to continue going down, except I'm not going down, I'm going across, gives me 2f equals 54. To solve for f, to isolate it, I need to divide by 2, which is doing the opposite of what the 2's doing to the f, which is multiplying. So I need to divide by 2 on the right-hand side. 2 divided by 2 on the left gives me just f. 54 divided by 2 gives me 27, and there's my answer, 27. Now, a lot of you will get kind of stuck right here saying that I'm done. However, the question was, what are both of the numbers? What are the two numbers? I only found one of them. The first is 27. I need to figure out the second. But I know an equation from the very start that I translated telling me how to find the second. The second is 56 larger than the first. So I'm going to take my first number and add 56. Or putting this 27 and substituting it into here, which tells me 27 plus 56 is 83. If you're unsure about that, you can go ahead and check yourself by adding the two numbers together to verify that it equals 110. So let's try that. 83 plus 27. Answer is 110, therefore we did it correctly. Let's try the next one. Two numbers add to 132, and the first is 14 bigger than the second. So I'm going to come over here, just like we did before, and I'm going to say that I have a first number, and I'm going to add it to a second number. And I don't have to use F and S, I could use something else. But I like doing that so that I know which one stands for what. And adding these together will give me 132. And I seem to have run out of room. There we go. So they told me something else. The first is 14 bigger than the second. The first is in math means equals. So I have first equals 14 bigger than. That's the same as less than, more than, and larger than in the fact that I need to put plus 14. So it kind of flips these two things around. Bigger and 14. So I add 14 instead of 14 add. Okay, bigger than the second. So I'm going to put the second plus 14. Now some of you are thinking, wait a minute, it doesn't matter. S plus 14 is the same as 14 plus S. That's true, but it gets a little confusing, and when you get to the less than, it does make a big difference because 10 minus something versus minus 10 from something, it makes a big difference. So go ahead and make sure that you reverse those whenever you see the than. Bigger than, lesser than, larger than, more than, one of those. Okay, now just like we did before, we're going to substitute S plus 14 in the first equation where I see the F. So instead of F now up here, I'm going to have S plus 14. So let's come up here. S plus 14 plus S. So I've substituted it in for F, then I need to add S, and equals 132. Okay, so now on the left-hand side I need to combine my variables. Adding those together gives me 2s plus 14 equals 132. Now I need to isolate the s. To do that I need to subtract 14 from both sides, which leaves me on the left-hand side 2s. Subtracting the 14 cancels, and I get 132 minus 14, which gives me 118 on the right hand side. There we go. Now again I need to continue solving for the s by isolating it. The opposite of 2 times s is divide by 2, and on the right hand side divide by 2. So the left hand side, 2 divided by 2, cancels, and I'm left with s equals divide by 2, 59. Yep, it matches, so we did that right. 59. But as tempting as it may be to stop and say that I'm done, I only found the second number. I need to find both of them. what are both numbers, the two numbers. So I need to substitute this 59 back into here. 59 plus 14 will give me the first one. And we got that from them telling us that the first number is 14 bigger than the second. Adding that together gives me 73. So that's the first number. And there's a way we can verify this by adding the two numbers and verifying that it does equal 132. So let's add 132. Good! All right, let's move to the next portion. Let's go ahead and make a part 3 on this, since this is already 25 minutes long, and we'll go ahead and move through the story problems and the formulas for the triangles and the rectangular solids and the cones for the next portion.